Hello and welcome to the short presentation of my paper about the fatigue strength of inner knurled component connections. The knurled interference fit basically combines the two well-known force transmitting principles, the frictional connection and the form closure. The connection is established by axial joining of harder knurled part into a softer smooth part where a counter profile is formed. As a result, a simple manufactured connection with a low tolerance sensitivity and high power density can be established. In present slide you see the two parts to be joined. These parts correspond, for example, to a shaft and a hub in any drive system. As the setup of knurled shaft and soft hub was already extensively researched in the past, inverse KYF is focused in present study. Here, the hardened hub with the inner knurling generates a counter profile during axial forming. The applications of knurled interference fit can already be found in several drive system assemblies. Of course, the design must comply with the high requirements of strength issues along the drivetrain. Therefore, the central question in present paper is about the torsional fatigue strength of inner knurled interference fit. In addition to the knurling geometry, the one parameter is crucial responsible for the properties of the joining. By changing the chamfer angle of first contact edge, one can distinguish between forming and cutting joining. For this, a hub chamfer angle of 15 degrees, which is representing the forming joining, and an angle of 90 degrees, establishing a cut counter profile, are investigated. First step is the joining of the shaft and the hub by axial force at joining speed of 0.5 mm per second. The joining length of 5 mm is reached. The force over stroke is recorded during the joining. This curve characterizes the type of the connection. The main investigations are done on torsional testing bench. The harmonic torque loading is applied to the joint specimen by means of stress control test. The stop criterion was either the loss of stiffness due to cracks or reaching of maximum load cycle of 10 million cycles. Further results showed the joining force of cutting joining method, which reaches always a lower level than the forming joining force. The grain analysis show also a higher deformation rate of forming joint shaft. Evaluating the results in strain cycle chart by means of staircase method, a 27% higher fatigue level is reached using the forming joining procedure. We can summarize that the hub chamfer angle affects the joining properties. The higher reached torque fatigue can be explained by strain hardening of formed material as well as by higher residual radial stresses, which correspond to the negative mean stress values. Comparing the connection notch factors, a similar fatigue strength is reached as the conventional press fit. Thank you and goodbye.